I'm Ellen Stofan, also known as Dr. E.
And I'm Thomas Serbuck, and also known as Dr. Z, and here's another episode of Easy Science. And we have a major milestone of one of our key missions coming up.
It's such an exciting mission. NASA's first asteroid sample return mission. The Japanese did it earlier, but this is NASA's first time. A huge technological challenge, but really critical because this sample is really a time capsule of the solar system. You know, Dr. Z, I was at NASA in 2016 when OSIRIS-REx launched. Incredibly exciting. And it actually launched on a rocket that we have a model of here at the Stephen F. Udvar-Hazy Center. It's the second one in, the copper-colored one there in Atlas V.
Exactly right. We built a spacecraft that was launched in 2016, got into orbit in 2018, did a remote exploration of Bennu, the size of the Empire State Building, a rubble pile of history of the solar system. And we looked at it and practiced and got ready to really go pick up a sample so we could bring it back to Earth and analyze it. October 20th, for 4.5 hours, we're going to grab that sample. It's going to be really, really hard, but the team is up for it.
So let's talk about why we're going to all this trouble. Obviously, Bennu is what's called an Apollo asteroid. It's an Earth-crossing asteroid, so its orbit intersects with the Earth's orbit. Now, obviously, that's a problem, right? Members of this family have hit the Earth in the past. In fact, we know there was a small Apollo that entered the Earth's atmosphere and exploded over the Russian city of Chelyabinsk a few years ago and caused quite a ruckus. So these asteroids this whole family presents a hazard to the Earth.
That's right. So within the next 200 years or so, there's a 1 in 3,000 chance that this one will hit the Earth, which is not very high if you think about it compared to other kind of risks. But needless to say, this is 500 meters, 5 football fields in dimension. And so it's a much bigger asteroid than the one we just talked about in Siberia, right?
And Bennu is an important type of asteroid because it's a carbonaceous asteroid. And we know these asteroids have amino acids in them, and every living thing on Earth is made up of amino acids, so we know those are critical components of life, the building blocks of life. And we suspect that comets and asteroids brought those to Earth very early in Earth's history. The other fascinating thing about these carbonaceous asteroids that I find really interesting is there's been recent work over the last several decades that these asteroids could have been critical in actually bringing water to the Earth because they're actually water rich. Tied up in the rocks of the asteroid is actually a lot of H2O, and our oceans and the water in our atmosphere came from somewhere, and we think it was actually dominantly asteroids, not actually comets.
What's also exciting about this particular body is we went there, right, and we found all these surprises. It's a highly saturated surface. It's a gravel pile. We expected from other asteroids that we've seen to have these sandy places with rocks there. Oh no, it's rocks on rocks on rocks, very few sandy places, which of course is a huge challenge for our mission designers, but also a challenge for our theorists. In addition to that, the asteroid is emitting these softball-sized rocks. They found them in a navigation camps. Like, oh, what is this? Like, it's moving. Like, you'd not expect that this body is active. So yes, it's really critical to our history, to the history of the whole solar system. But it's also, as a world, it's a really exciting and rough place to be at. Dr. E, I can't let you go without talking about Venus. Venus has been in the news so many times about life. Can you explain us?
Sure, and a lot of people might be puzzled about that. They might know that Venus has a runaway greenhouse atmosphere. It's almost 900 degrees Fahrenheit on the surface. But you know, back even to the early work of Carl Sagan, it has been supposed that in the higher levels of the Venus atmosphere, where the temperatures are much cooler, and the atmosphere is actually fairly stable, which means clouds can persist for maybe thousands, hugely long periods of time. Could you have some sort of life form living in the clouds of Venus? A lot of speculation, never been able to determine if that's true or not. So just recently, a group of scientists detected a gas called phosphine in the atmosphere of Venus. Now on the Earth, phosphine is associated with life, but it also can be created through other processes. For example, you find it in the atmospheres of Jupiter and Saturn. So this is an intriguing result. There's not really a great reason why there should be phosphine in the atmosphere of Venus. So is it related to life? Does it have some other cause? So this is just one more reason that we need to get back to Venus. It's a planet the size of the Earth. It's gone through a very different geologic history. And it really helps us understand when we go to other solar systems to say, why did you have one planet in our solar system that became Earth, became this lovely habitable planet that we all live on, and you have Venus that went down a very different evolutionary path?
Yeah, and in fact, 2 of our 4 candidate missions in the Discovery program will go to Venus and look at various parts of Venus if they get selected. Also, Io is one of the targets, and Triton, the moon out there by Neptune. So needless to say, there's many amazing targets in the solar system, and Venus is just, we see it in the sky many evenings. It's more and more exciting to think of the science that we could explore there.
In the meantime, come visit us here at the Stephen F. Woodvar Hazy Center in Chantilly, Virginia. We're open for business. You need a free timed entry pass. Come see the wonders that we display of the history of aviation and spaceflight. And of course, stay tuned for the next episode of Easy Science.